Pretty much every mainstream programming language nowadays contains a concept called a lambda function, and this concept was borrowed from lambda calculus and functional programming. And what lambda functions allow you to do is, rather than declaring an entire function to do some simple functionality, what you could do is just easily create a tiny function that could do useful stuff. And most of the time, these functions do not have a name. Like for example here, this function has the name do something. But in this case, I'm going to assign this function to a variable. And in most programming languages, you could actually pass functions around like a normal variable. And I'm just going to make another variable here, and I could pass the lambda function to this function and just call this function as if it were a normal function. And the same applies with do something. And pretty much the way that you would use a lambda function is just as normal. So I'm just gonna give an example here. So I'm gonna log do something, and I'm gonna pass in 1. Then I'm gonna repeat the same thing with the lambda function and the variable which I passed do something with. And to make it more interesting, I'll just add 2 to this one. And now if I run this program, then it would give me 232. Now when I run do something, all it does is it adds 1 to n. When I run the lambda function, it adds 2 to n. When I call the function, this variable, or this thing that I assigned to do something, then it would just call do something. So that's how that stuff works. And passing it around variables isn't that interesting, but what you could do is you could pass it into other functions. And when you do this, the function that you're passing this lambda function into, or any function into, is called a higher order function. And this higher order function, like I mentioned, will take in a function. And since I'm using TypeScript, I could actually define the type which I want to be inside here. So it's going to be a function that takes in some number and return a number. Now, if I wanted to use this function inside this other function, then I could just use it normally. And if I were to call this higher order function with some value, then, or I need to actually pass in the lambda function, and let me just log the result of this function. And if I were to run this function or this program, then you would get 5, 3 plus 2. And you might be wondering, how is higher order functions useful? And I'll get to that in a minute. But something that I wanted to mention is you might have heard of something called a closure in JavaScript, and what that allows you to do, or the concept of a closure, is, let's say that you have some array, and this array contains a bunch of values, and this would need a different example, but I'll take this function to have to take in a number, an array of numbers, and return an array of numbers. And what I could do is I could return some lambda function that runs this function over here. So when so pretty much what this would do, or I'm just gonna, rather than return some value, I'm just gonna return void. And what I'm gonna do is just take this number array and just print it, or add it to the log. And what happens here is it would return some function. So I need to actually get the result of this. And if I were to call this function, then it would run this function, but this function would take in this array object. And let me just run the program, and we would get this array. Now, what's going on over here? So you call this function, and when the function is over, then you might think that everything inside this function is erased, or you can't access anything inside this function anymore. But since there is concept of a closure, this function actually stores the reference to the array, so you could still access it even if you are not inside the closure of this function anymore. So I just wanted to mention that. And now for higher order functions. So the best example of higher order function is going to be with some libraries such as Express or frameworks such as React. You use Lambda functions extensively within those frameworks and libraries, but the most commonplace application that you would see higher order functions in is to just operate on arrays. So let me just make some array of numbers, and this array of numbers would just contain a group of numbers from 0 to 99, let's say. So I'm going to create a new array that has 100 values, and then I'm going to fill it to contain nothing, or just contain the number 0. And I could do something called a map operation. And what this operation allows me to do is pass in another function within it. And what this function allows you to do is it would take every single element inside this array and then call this function. So what's going to happen here is that this array is pretty much filled with a bunch of zeros, and I just want to fill it with a bunch of values from 0 until 99. So what I could do is I could ignore the first value because it's going to be 0. So the way that you would do that is in the first parameter, and in the second parameter it turns out that they give us the index. And if you look at the definition for map, then this is the callback function. This is the first parameter, which is the actual element that is being looped over, and an index of that element, and the array itself. So here I'm not going to be using the value, and the convention in JavaScript and TypeScript is to put a underscore in front of the variable that you're not going to be using, and it makes if you have a linter, then there's probably a rule that doesn't allow you to use any not use any parameters. So this just tells the linter or the compiler that you are not using this variable. So the first variable is the actual value, and the second variable is the index. So I'm just gonna use the index to fill this array. And what I could do is, in this case, or let me just print out this array first so I could log it. And what we should get is an array from 0 until 99. So as you can see, this is an array from 0 to 99. And what we could do is really easily change it to be from 1 to 100 by just adding 1 to every variable. And that is the result from 1 until 99. And this is just one of many examples of higher order functions. And it turns out that there are plenty of higher order functions that you could use with arrays. And one of them is just ForEach. So what map does is it runs some function that takes in the value, and in JavaScript at least, it takes also the index and the entire array, and you could map this element to another value, and it repeats it for every single value inside the array. And what ForEach does is it would take the same arguments, so the value and the index and the array, and then it allows you to do something with it, but it doesn't care about anything that you return because you are not, it doesn't expect anything in return. It's a callback function that returns nothing or void. So what I could do is just log it to the console, and I could just log the actual value, and it would give me every single number from 1 to 100. So it seems that it looks like it works. And what I could do is maybe I don't want the even numbers, or I want the even numbers, I want to ignore the odd numbers. So I could use something called a filter. So this filter um, would remove any element that is not true. So I'm just going to take the value, and if I'm not going to use any more arguments than one, I could remove the parenthesis, and I could say if the value is divisible by 2 or even, then I want to keep it. Otherwise, I want to remove it. Let me clean up this code, and if I run the program, it should give me only the even numbers, which is what has shown up in the terminal. Now, maybe I want to add another filter. So maybe I want to filter, or I want to keep the numbers which have a factor of 2 and 3. So I could just create another filter to do that. And you might be wondering, okay, how is this chaining going on? This is something called chaining. So what this function gives you or returns is an array of stuff. And this array of things also gives you an array. And this array has a map method. And this map method returns a number array. And this number array contains other methods. So that's how this chaining is working if you haven't realized. And if I were to run this code again, let me save it first, then it should give me all the numbers that have a factor of 2 and 3. So this looks about right. Now, there is a fourth higher order function that I wanted to show, and that is the reduce method. And what the reduce method allows you to do is, like the name says, reduce the whole array into a single value. So what this function takes in is, like the other methods, it takes in a lambda function or an ordinary function and an initial value, and this is called the accumulator. And inside this callback function, it takes this accumulator again, and it takes in the current element of this array. And what I could do is get the sum of all the elements inside this array by just running this command. And what I could do is I could take this accumulator and I could just add n. And then it would return the entire result. So this is more, if I were to name this better, it would be result. And if I were to log result, then I should get the sum of all the numbers that have been remaining inside this array. So this seems to be the sum of all these numbers. And the last higher order function which I want to showcase is the sort. method, and what this method allows you to do is sort an array. It doesn't need to be an array of numbers, it could be an array of strings or a bunch of enums or whatever. But what it allows you to do is pass in some function, and this function pretty much tells you how you should be sorting this array. And the example that they give here is that if you wanted to so let me just try it. So if I were to say a minus b, and these are numbers, so the way that I would sort it is ascending. So if I were to do the opposite, then it would sort in the opposite way. And if you create some, so that worked. So if you create some custom sorting method, then, or sorting function that just tells this um, tells this sort function how you should prioritize two elements, then it could sort the entire array without needing to implement some complex sorting algorithm from the top of your head. And this uses a pretty efficient sorting algorithm, as far as I could tell. I believe it's some kind of merge sort, so that's not something that you would want to implement yourself, but it's really handy to have in your arsenal when you just want to quickly sort some array. And you don't need to worry about the implementation. You could just pass in some function to sort anything. And rather than now, for most people, it's kind of hard to understand these higher order functions. So what I'll do is, rather than trying to explain it further, I'm going to actually implement them. So let's see the ForEach method. Now I think that the ForEach method was the simplest one to comprehend. So let's try it. So it's a function, ForEach, and this function will take in an array, and it would take in some function. Now this is TypeScript, so I would like to describe the types of all these parameters that I'm going to be putting in. And what I want to do is create some function that is generic. So I don't care what's inside this array. I just care about going through every single element in this array. So I could just say it's of a certain type, and I could create this function into a generic function by just adding these. I don't remember what these are called, but I could just add these brackets and say this type here, and now it would become a generic function. And inside this function, it would take in the current value and the index and the entire array, and then it would return something, or in this case, return nothing. And the value is just going to be t, because this is an array of elements of type t, so every single value would be of type t as well. And the index is just going to be a number, and the array is going to be the same thing as, it's pretty much the same object as this. So it's an array of types, of elements of type t. And let me just zoom out a bit. And pretty much what's going on is that I'm going to be looping over every single element in this array. So I equals 0, I is less than array.length, and then I plus plus. So pretty much this would loop over the array, every single element in this array, and it would call the function. And when it calls the function, it's gonna, I need to pass in the value, the current element, and the index, as well as the original array. And in some cases, it's pretty convenient to have the index and the array if you want to do something more complex. But if you just wanted to log the every single element, for example, you only need the value. But just in case the user of this function decided to use these values, then they could access it. And a nice thing about JavaScript is, let me just uncomment these, but if you don't want to use any extra parameters in a lambda or in a callback function, then you don't need to add it to the parameters of this function. Like, you're just gonna ignore it. So I'm just adding this in case the user decides to use it. And now I could just use this for each function on some array, and I'll keep this array as is, so I'll just use a result, and I'm gonna take in the value. I'm just gonna log the value. And if I were to run this code, it should hopefully give me every single element inside this array, which is what it seemed to do. And like I mentioned before, you could pass, rather than trying to pass in my own Lambda function, what I could do is I could just pass in console.log directly. And what this will do is give me, oh, it's a bit slow. Okay, so what it did is that this is the value, this is the index, and this is the original array. So console.log takes in more than one argument, so it's taking in everything. But I could just pass in the console.log function directly, and that would work. So this is how the ForEach function works. I'm not going to go over this sort function because I'm not going to be implementing merge sort in a video. But maybe the next best option is map, I believe. Yeah, sure, map. So it's going to be very similar to ForEach, but in this case, I'm going to be returning. So I'm going to take this function, and this function would return a result. And what's going to happen is that it would take one array and it would transform it into another array. So this is the type of the original array, or the type of every element in the original array, and I might decide to change it to a different type. So this is why I like TypeScript. You could be very specific with the types. But I'm going to take in an array of t's, or of elements of type t, and I'm going to return some element of type r. And I added it to the argument list over here. And what I'm going to do is create a new array, and this array will be empty. And I could define this type to be an array of type of elements of type r. And then when I'm done with it, I could return new array. And every time I call this function, it would give me, I give it all the instruction or the data it needs for every element inside the original array, and it's going to return some mapped value. So what I could do is say new array, then I could push, which would add it to the end of the array, and I could push the new value, which I just mapped. And now let's try it out. So I could say map, and then it would take results, which is the array from 1 to 100, and let me just increase the value by 1. So I could take n, and I could say n plus 1. So I just increased the number by 1. And I feel kind of so like I showed here before, you could chain these together, and the same goes with these, but you're not going to be doing dot fill and dot map, so it won't look as pretty as this, but you could still do it. So for each, and I could pass in the result of this, which would give me an array of numbers, so it's still valid. And what I could do is just take the number or the value and log it to the console. And now if I were to run this, then it would increase every number by 1, so it would start at 2 and go to 100, 1, and it would stop there. So it doesn't look as nice, but you could still chain these functions together. And the third one that I would write is the filter function. And what the filter function does is it takes this function and it returns a boolean. So do you want this element to be inside this array or not? And it'll have the exact same concept where you're creating a new array, but rather than having some new result, it would be the exact same array. And my bad, this is gonna return an also, by the way, TypeScript is smart enough to infer the return details or the return type. So over here, it could tell that the return type is an array of t's or elements of type t, just because new arrays of type t, and it's returning that. And what I want to do is for the callback function, I want it to return a boolean. So whenever this condition is true, so I'm just going to copy this. So whenever this is true, then I want it to push this element into the new array. And there's a problem. I forgot the parenthesis. So pretty much what's going to happen here is it's going to create a new array. It's going to go through every single element in this array, and depending on the result of this function, it decides whether it should add it to the new array or not. And then it would give me this new array. And I'm not gonna chain it again because I don't want it to be confusing, but I'll just change this to filter. And in this case, I want to just return some boolean value. So that is okay. Argument of type number defined. Okay, let me just write filter result, then take this number and get the modulus of 2 to see if it's even, and then let me get the result. Now this filtered array, okay, so the for loop, I didn't close the for loop, so I believe that was the problem earlier. So let me just close this for loop, and if I were to run this, it should give me all the even numbers. So that is what it's given me. And now for the fourth and final one that I'll be showcasing is the reduce function. And this reduce function is possibly the most powerful one, and I'll show you why in a sec. But what it's going to do is it's going to return some accumulated object, and I'm just going to pass it inside the parameters directly. So it's some accumulated object, and I'll just say result as well. So it's going to take and also I forgot to mention, but um, TypeScript can also infer the type of this generic function just from the array. So you don't need to manually describe what t is, but if you wanted to, you could. So you could say you want this to be a string, and now result would need to be a string, and n would be a string, so you can't get the modulus of 2 of it. And you could do that if you want to just double check to make sure that your code isn't wrong. Like let's say that you're doing a map operation and you wanted to, and this will take a number, and well, the types that you're going to be passing in is you're going to take in a normal array of numbers and you're going to map it to something else. So maybe you wanted to take in an array of numbers and you wanted to map it to an array of strings. So you could do that. Now it's TypeScript is telling me you're doing something wrong. I'm expecting a string, but it is giving me a boolean, and I could just do in.toString. Now if we were to run this program, it would convert everything into a string. But okay, so let me count this out for a sec. Okay, so the way that you differentiate numbers from strings in the console is, as you can see, this is yellow, this is white, so this is just a normal string. So this map operation actually worked. Now for reduce, what's going to happen is that it takes in some array of type t, elements of type t, and it's going to return some accumulator of type r. And rather than, so the whole goal of the reduce operation is to stuff all the elements or all the data that you want in the elements into this accumulator. So I'm going to return this accumulator because that's the result that we want. And I still want to loop over every element, but I will be setting the accumulator to result of the function. And in the function, I'm just going to follow the definition that I gave it. So it's going to take in the value, which is array of I, and then array. So this function over here will be returning type R because it's returning the accumulator. And pretty much this is the definition of reduce. So if you could tell, this is the most powerful higher order method for arrays, at least, because you could do pretty much anything with it. Like it's not limited to just an array. You could, like I showed you before, you could get the sum of the entire array. And I'm going to be doing that right now. So I could get, I could reduce this result array, which is the array from 1 to 100, and I could, and this function takes, this reduce higher order function takes in a lambda function, and I'm going to fill that in a second, and it takes some accumulator. Now, what's going to happen is that it's going to do 0 plus the first element, plus the second, plus the third, plus the fourth, plus the fifth. So the only value that makes sense here is 0, and the built-in reduce function takes in, rather than taking an accumulator, the accumulator is optional, and it could be just the first element, but just to reduce the complexity of this reduce function, I'm going to pass in manually. And what I could do is I could specify exactly what the type of the return thing would be. So I could say number, and this thing that I'm going to be returning, the accumulator, is also going to be a number. So whatever I return here must also be a number. So if I look at the arguments that I'm giving myself here, this is actually wrong. So it's taking in, or a reduce function should take some accumulator over here as well. and the accumulated value, the current element, the index of the element, and the array. So I'm gonna take in the accumulated value and then the value. So what I'm gonna do is just add the accumulated value with the actual value, and that's gonna give you something that's really similar to this. So that should give me the sum of all these numbers. And pretty much all the things I've showed you earlier can be done using reduce. For example, if I wanted to uh, print out every element, I could do that. So this is just going to be a void, and I'm not going to use the accumulator, and I could just put nothing here. And this thing would be, or unknown, that's probably a better value, and I could just console.log the value. So then it should print out every single value. And I don't want to log this anymore. Actually, let me put this into a second result and log it, just in case we need it later. So pretty much if you're stranded on a desert island and you need to pick through one of these higher order functions, choose reduce, because you could do everything with it. And if I wanted to map all the values to a different value, what I could do is this accumulator will be another array, and this I'm pretty sure it won't be able to understand what I'm doing, but this is also like the result is going to be an array of numbers. So right now it's telling me whatever you're doing here needs to be an array of numbers. So what I could do is this accumulator is an array of numbers. This is a number, so I want to add this number to the end of the array of numbers. So what I could do is use something called the spread operator and then add the value to the end, and I'll probably explain the spread operator in another video, but pretty much this creates another clone of this array, and then I just append this other value in the end, then it just creates a new array. So it's pretty handy syntax, and I would need to actually log the value now, but this would map. Okay, so how is this a map? I could just say +1 over here, and then it would pretty much do anything that I want to do with a map. So it just added 1 to every single value. If I wanted to filter it, I'll show you a different way of doing this and to be honest, it's a more optimal way because you're not creating a new array every time, but you could just say accumulator.push v, and you could just return, and you could do this, but it's longer, and when you're writing long code with this, you might as well just use a for loop. But so that's why I used the spread operator earlier. But if you can, you should try using Lambda functions to be just in a single line, but sometimes it's unavoidable, like in this case, or I could make some function that does that, but I'm not going to. But pretty much this would just add it to the end of the um, accumulated array, and this would be very similar to what I did earlier. So the map function, so it should give me the exact same result. So from 2 to 101. And now finally the filter function. So I could do something really similar to this. So if I'm happy with this variable, for example, if it's even, then I'll add it to the accumulator, which is this array. Now if I were to run this, let me remove the +1, then it should give me all the even numbers. So like I showed you before, you could replicate all the same behavior in a reduced statement as you can with others, but you are you're writing more code in some cases, like the map and the filter. So it's a multi-use tool, but there could be other tools which are better. And the most interesting, or the thing that I use reduce the most with, is converting some array into an object. So I could make the accumulator in some object into some object, and hopefully, I'll just say any for now because I'm not gonna write type for this. But I could take the accumulator and the value, and also take the index. And what I'll do is I'll create a new object, and like I did with the array spread operator, I'm gonna do it with an object, and I'm gonna create a clone of this object here, and I will okay. So the thing with callback functions is that it expects this to be like the body of the function. So if you're going to be creating some new object, what you need to do is add these parentheses so it knows that you're trying to return some JavaScript object. Now I'm going to have the key as the index and the value of each thing to be this. Now if I were to run this, then it's give me one big object with this is the key or the index of the array and the value in that index. So that is pretty much the higher order Lambda functions and higher order functions.